This is TWiT.
So, our podcast 2 weeks ago was titled Dependency Confusion. And we need to spend some more time on this issue because this is really bad. And after, explaining what dependency confusion was all about, and noting that this is currently a fundamental design weakness and readily exploitable flaw within the industry's package managers and project build logic used pervasively throughout the industry, it was clear that this was going to be a large problem for quite some time. And that unfortunate expectation is being realized quickly. So stated as briefly as possible, dependency confusion amounts to a by design backdoor into the internal build servers and private code repositories of a vast number of software publishers, large and small. The UK firm Sonatype first blogged about their findings from their security instrumentation last Monday. So this Monday, that was like the 1st of March. Their post was titled Newly Identified Dependency Confusion Packages Target Amazon, Zillow, and Slack. And they said, go beyond just bug bounties. They wrote, Sonatype has identified new dependency confusion packages published to the NPM ecosystem that are malicious in nature. These squatted packages are named after repository namespaces or components used by popular companies such as Amazon, Zillow, Lyft, and Slack. As previously reported by Sonatype, Alex Berson's dependency confusion research, and that's what we talked about 2 weeks ago, disclosure, led to copycat publishers publishing 275 plus identical packages to the NPM repo within 48 hours in hopes of scoring bug bounties. The number then jumped to over 550 within the next few days. As of today, Sonatype's automated malware detection systems, part of Nexus Intelligence, which is their proprietary technology, has since identified well over 700 NPM copycat packages based on Berson's proof of concept. Although ethical hacking for bug bounties and spreading security awareness has its place and is even welcomed by the community as it keeps us all more secure, the copycat packages recently identified by Sonatype unfortunately crosses the line of what is deemed ethical. So that was Monday. 2 days later, their follow-up posting was titled PyPy and NPM flooded with over 5,000 dependency confusion copycats. So this has predictably morphed almost overnight into an industry-wide siege on the software industry's use of third-party package libraries. And Sonatype notes that these are not all just white hats hoping to score a bounty. They wrote, as soon as these packages are installed automatically, because they share a name with an internal dependency, therefore exploiting dependency confusion, they exfiltrate the user's .bash_history file and etc/shadow directory, and in some cases spawn a reverse shell. The etc/shadow file, they note, is a successor to the etc/password Linux file that maintains hash-based password data of user accounts on the system. So these are no longer benign. The exfiltration goes well beyond bug bounties at this point. The original discoverer and publisher of this disaster, of course, Alex Burson, whose work we described 2 weeks ago, was extremely careful not to do anything that could be construed as malicious. He understood that if he posted confusing dependencies that would confuse the dependency managers, he would be executing code on somebody else's systems. And so he deliberately used simple DNS queries as a means of indicating the success of that probe. The fact that it's extremely difficult not to use this for malicious purposes demonstrates just how easy it is to use it for malicious purposes. And despite being warned about this by Alex's original work, remember that Microsoft was one of the companies he said, Microsoft, you want to go look over here because unfortunately your servers are sending DNS queries to mine, meaning that you have picked up external code and are running it. In a follow-up experiment, Microsoft Teams was deeply penetrated. Last Thursday, Matt Austin, the director of security research at Contrast Security, described his successful use of dependency confusion against Microsoft. This is enough of a problem that I think it's worth sharing a bit of Matt's description just to drive his point home. So here's part of what he wrote. He said, dependency confusion involves the creation of packages on third-party libraries that have identical names to packages stored in a company's internal repository. The goal is to trick developers and automated systems into using the wrong library because of defaults configured into package managers that show a preference for external libraries over internal ones. He says, so while it should be difficult for external users, whether bad actors, legitimate developers, or security researchers, to even find the names of packages stored in internal repositories, Burson was able to find the names of these packages in the applications themselves and was able to replicate that accomplishment over at least 35 applications. Since Burson's research was published, multiple reports of bad actors using the technique have started to appear. In addition, other security researchers, he said, including myself, began exploring various software-as-a-service-based applications to see whether we could find dependency confusion vulnerabilities that could be exploited by attackers. A member of the Contrast Labs team, he said, and he meant as a member of the Contrast Labs team, I specialize in security research on applications created with the Electron framework, including Microsoft Teams. Previously, I've discovered and reported several remote code execution vulnerabilities in that application. Given my background, I decided to contribute to the effort by examining Teams to see if I could identify a dependency confusion vulnerability. He wrote, I began by looking at the dependencies used by the Teams desktop application. In one section of the application, I saw a Node.js package called optional dependencies. He said, typically, the intent of optional dependencies is to provide a place to store binary files that are part of the testing suite, but not the production application. The interesting thing about optional dependencies is that they do not exist in the repository from which a developer is trying to pull them. I'm sorry, if they do not exist in the repository from which a developer is trying to pull them, the build will fail silently. Thus, developers must write code that is relatively defensive when optional dependencies exist. Specifically, one cannot depend upon a dependency that is optional. He says, inside the team's desktop application is a package file that lists the dependencies that the application needed in order to be built. Again, inside the team's desktop application, meaning like, right, what the world has installed on their desktops. I think it's 150 million instances, is a package file that lists the dependencies that the application needed in order to be built. When one downloads and installs the application, it does not reach out to the dependency managers. This is because every part of the application is built on a Microsoft server somewhere, after which it is shipped to customers. But the point is, this still was a massive, important information leakage. I have in the show notes a picture from his posting, which shows the package.json and the optional dependencies JSON information with the names of the dependencies and their version numbers just right out there. That was in the desktop application. So he says, now back to what I discovered. When analyzing the package, I noted a number of modules in both public and private repositories. I also saw that some of the private packages were not taking advantage of the scoping capability provided by NPM. In other words, making sure they were scoped locally so that they would not be scoped globally. He said, I noted that some of the optional dependencies did not exist on disk inside the package itself. This means that during the build process, those dependencies would not be found in any repository, public or private. By design, these optional dependencies failed silently whenever the application attempted to pull them from both public and private repositories. I then selected one of the modules that was listed as an optional dependency and registered it on NPM, setting the version to 0.0.1. I added a simple line of code in the install script of the package to alert me when it was installed. Once I was ready to deploy, I set the version of the module to match the version number from the application. At this point, I had two choices: bump the version number up by 1 and wait for Microsoft to update and pull in the new version, or keep it at the current version and hope that a build server would pull in a fresh copy of it. And he says, parens, not using packagelock.json. He says, there are risks either way, but I decided to do what would be the least impactful, keeping the version number the same. As soon as I set one of the dependencies to a high enough version, I started getting requests from the module being installed from a number of internal Microsoft IP addresses. The name of the module was relatively generic, but it was Microsoft specific and not an overly common word. He said, I happened to be doing this research late at night. Based on that and other factors, I deduced that the responses were most likely from internal automated resources within Microsoft that were pulling the dependencies and installing them. Perhaps an automated continuous integration, continuous deployment server. But it could also have been a live developer working a late shift in the US or daytime shift somewhere overseas. Whether the responses I saw were automated or manual, the fact that I was able to generate this reaction poses significant risk. By taking advantage of the post-install script, I was able to execute code in whatever environment this was being installed on. If attackers were to execute code the way I did on a build server for a desktop application update that was about to be distributed, they could insert anything they wanted into that update, and that code would go out to every desktop using Teams, more than 115 million machines. Such an attack could have monumental repercussions, potentially affecting as many organizations as the massive attack on the SolarWinds software factory that was revealed in December. And I would argue significantly bigger than that. So I wanted to drive home the point that this will not be easy to fix, and that it is going to be a source of immense, long-running pain for the entire industry. This is similar to the first time someone observed that a deliberate buffer overflow could be abused to execute attacker-supplied code on the stack. Today, everyone knows it, but there was a time when that had never occurred to anyone. And this is like that. You know, look at what an enduring problem buffer overflows have been. I would argue this is no less significant. A lazy and thoughtless approach to package dependency management has pervaded the entire software industry. It is already everywhere, and it's going to take a lot of work to pull all of it out by the roots. So, this has, the abuse of this has exploded since we talked about it for the first time 2 weeks ago. Basically, anything a developer tries on who's wearing a white hat succeeds, because these insecurities have been built into the architecture without giving thought to how they could be abused. It has to be the case that right now there are dependency problems of this kind, these sorts of confusions, which are installing malicious code in packages, and we don't know it yet. So anyway, I mean, this is, whereas what we're going to be talking about as our main topic in a minute is a, huge, obvious, in-your-face crisis. This one is far more insidious, and I don't know how it will be that will tie back future exploits to this having been the way. But if any of them are sufficiently big, and then enough people apply forensics, we're going to end up figuring out that, yep, this came from a dependency confusion where some bad guy simply registered a funky named package on NPM or PyPy or any of the other public repositories. It got sucked into some random but important company's build, and then they shipped this thing out to everybody. It's breathtaking in the essentially in the leverage that this creates, which is why this is such a problem. And here's Microsoft. This is months downstream of when they were first informed of this, and whoops, caught them again, even though they well knew. That's my point, is that this thing, it's hiding unless you look. And how many companies out there aren't on the, like following the latest security news? They're just busy getting their work done. And, what was that? Well, we'll think about that later. Meanwhile, their build system is pulling a malicious code in and replacing their internal package with something, and out it goes to their customers. It can't be overstated.